So section 4.3, number 11, it's solve tangent 4x equals 0. The instructions say to find all real numbers that satisfy, so we're doing infinite answers. So we start by ignoring the fact that it's a 4x, and we just think about where is tangent 0? It is 0, right? And then it repeats every pi. Good. So 4x is going to be equal to 0 plus it repeats every pi. So we don't even really need the 0 because it's just going to be values of k pi, isn't it? Because it's 0 and then pi and then 2 pi and then 3 pi and then 4 pi, right? So then, because it's a 4 times the angle, we now have to do this last step, which is what? Divide both sides by 4. So we end up with our answer k pi divided by 4. Should be all real solutions for values of k that are integers. Right? Anything else just to refresh your memory on this stuff? Oh, it's one of those good review ones that you guys need. Okay, this is exactly the type of problem I've been throwing on self-starters to just make sure you've got extra work on them here. Find the exact value of cosine negative pi over 12 using, no, that's the wrong one. Find the period. I started reading the wrong question. So we're finding the period, the asymptotes, and the range. We don't have to find the phase shift. So since we don't have to find the phase shift, do we care about factoring out the 2? No. If we did, you know what, I'm going to make you do it anyway. Here we do it. Phase shift, what would it be? Just right now together, let's do the phase shift. Good, because you'd have to divide out the 2. Divide out the 2, so you have x. And if you divide pi halves by 2, you get pi fourths. And since that's positive, it's going to be left. So we usually say that with a negative. Negative pi fourths. Make sense? Okay, but that wasn't part of the question. Okay, the period for cotangent is what? Normally. Normally the period for cotangent is pi. That means that the piece of the graph repeats every pi, right? But because we have this 2 here, what does that 2 mean again? 2 means we're going to have 2 repeats where we normally have 1. So we're going to have 2 repeats in pi instead of just 1. 2 cycles in pi. So in order to find the period, we take what it normally is, which is pi, and we divide by the number of repeats, and we get the period pi halves. Okay, asymptotes. So let's write down what Bryce said, and then we'll check and see if he's right. So he says it's pi fourths plus k pi halves. So x equals, right? That's important when you're doing equations for asymptotes. You've got x equals that. Okay, so there's Bryce's answer. Let's see if he's right. Okay, let's think about the cotangent graph. Normally the cotangent graph looks like what? So here's pi, here's 0. It usually goes like that. Is that right? Am I remembering right? You guys check my answer. Because tangent of 0 is 0. So tangent's the one that goes through 0. And cotangent goes there, right? Okay, so where are the asymptotes normally located? So the asymptotes would normally be at x equals k pi. But because we're getting 2 where we normally have 1, we would take what that normally is and divide it by 2. So for this problem, the asymptotes would be x equals k pi halves, because we divide that by 2 just like we divided the period by 2 to find it. So, sorry, Bryce. You had part of it right. You just were doing kind of tangents instead of cotangents. Okay. And then the range. What's the range? That should be super easy. Yay. Nice. Nicely done. All right. Looks like we still need to keep hitting this frequently, right? Keep practicing where those asymptotes are. Keep working on it.